Hi and welcome to John's Maths book. In this video, I'm going to be looking at evaluating the indefinite integral tan theta d theta. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. Let's look at how we find the indefinite integral of tan theta d theta. To evaluate this, we need to use a trig identity to replace tan theta with something that we can more easily integrate, and then use integration by substitution to arrive at the final solution. Let's begin by using a trig identity to transform tan theta such that we have a function that is more easily integrated. We'll use the trig identity tan theta is equal to sine theta divided by cos theta. So now we've transformed the integral of tan theta d theta into the integral of sine theta divided by cos theta d theta. Now to integrate this, we're going to use U-Substitution. So let's start by letting U equal cos theta. Du by d theta is equal to minus sine theta, and it follows that d theta is equal to minus du over sine theta. So now if we substitute for cos theta and d theta, we have minus the integral of sine theta over u multiplied by du divided by sine theta. The sine thetas cancel out and we're left with minus the integral of 1 over u du. The antiderivative of 1 over u is the log of the absolute value of u. So we're left with minus the log of the absolute value of u plus a constant of integration which we can call c. If we now substitute back in for u, which we know is cos theta, we have a final answer of minus the log of the absolute value of cos theta plus a constant of integration, which we'll call c.